Hi folks, today we are going to be starting a series for this project. I'm just gonna pronounce it PNGme. I know it's supposed to be something like PNGme from PNG message, but it doesn't exactly roll off the tongue, so I'll just go with PNGme from now on. Pardon me if that bothers you. This is recommended as an intermediate Rust project. I would say that it's a good way to test your knowledge of the basics in Rust. And it's just a very fun project that you can get your hands dirty. The main gist of it is that we're going to be writing a library and a command line tool that can open PNG files and that can then encode secret messages into them. I would recommend initially going through this on your own before watching the videos. Even if you can't wait to do that, I would still recommend watching the videos and then at the end trying to do the exercises without using the videos for step-by-step guidance. This way you're gonna get the biggest learning experience from it. Lots of thanks to the project's author. It's been a really useful assignment. Of course, I'll leave the link to the resource in the description of the video. Okay, I'm not gonna read the introduction. You can have a look on your own. I'm just gonna go to the setup section. All right, let's see. Okay, so we have to create a new binary. Then we have to copy the contents of the page on the main file. Okay, and also replicate the file structure with the modules here in order to get it to compile. Let's just copy this. I'm gonna go to my terminal. Let's create a new binary. We're just gonna use the exact same name. It's okay. Now let's open it. All right. Let me just, I think I'm gonna adjust the view a bit for better visibility. Okay. All right. Let's just paste the new contents. Let me open up the terminal. I'm gonna go into the source folder. Let's just create the missing files. So args.rs chunk type commands and PNG. Okay, we've got the setup going. Let me just actually cargo check this. Okay, looking good. Let's go back to the docs. Okay, and let's go to the first section. Okay, so this is for the PNG chunk types. Here we have a link to the PNG structure specifications. Just gonna open this. Actually, let me go back. I'm gonna open this in a new tab. So essentially, a PNG is made of a signature in terms of bytes, which is this in the file, and then is just a collection of chunks that represent different aspects of the data contained within. And each chunk has these 4 parts. And these are pretty simple since they're essentially, this is just a number, this is also a number, This is the data, the raw data in the chunk. And this is the chunk type, which has a special significance. It kind of represents what the chunk does, or what it's supposed to represent. Now, the chunk type can mark text data that's represented as metadata for the image. It can also mark transparency or color data, like all sorts of things. There are special codes for this. All right, let's go back to the requirements. Okay, it tells us that we are going to be working with bytes. Tells us about some utility methods. Again, just read this for yourself when implementing the exercise. And let's go to the assignment. The author of this project gives us some unit tests to check if what we implemented is correct. And it tells us to just copy the unit tests. Let's just copy these, switch to the IDE, and this is supposed to be in this file. Okay. I think the warning is out of hand. I'm just going to paste this. And I'm just going to have to delete this. I think it just needs to reindex. All right. So we have the tests. Okay, so we have to define a chunk type. We have to implement try from string and display. Okay. Derive partial EQ, and we need these methods. I'll just copy the signatures right at this point. Let me close the sidebar for better visibility. Just gonna leave the function signatures here for now. Can also close, can minimize the terminal for now. Okay. Okay. So the first point of business would be to define the actual chunk type. Let's go back to the docs a bit. Actually, the PNG specifications. Okay, so we can see here that the chunk type is made from 4 bytes. And each of the bytes can represent an ASCII letter, uppercase or lowercase. Let's go back to the IDE. And I think we can just store the bytes in the type. That would be the simplest. So let's try that. See chunk type. And let's say bytes. And this should be a vec of U8, size 4. I think this should be good. Okay. So it also wants to implement try from the bytes. And let's say implement for chunk type. Okay, this is gonna throw an error. Okay, I'm just gonna leave this for now. Now I'm gonna follow up with the next point. From string, implement from string for chunk type. I think this isn't imported, so I'm just gonna, all right. Let's cover an implementation. And we also had to implement display for chunk type. Okay. Let's fill up the methods below so we can get the project to compile. Okay, so, I think this should work. Oh, yeah, the problem is I have to move these in an impl block for the chunk type because they're methods. Okay, can just move. Okay, this one is good. Okay. Let's just return true. As well. All right. Same here as well. There's also a small problem here. When you copy the code, it wraps it in a main function, which we didn't want. Okay. Huh. Let me check. Yeah, I think I can just remove the warning for now as well. Let's just format this. All right, now let's try our hand at some of the implementations. Okay. So first, try from U8. This should be pretty simple because we just need to store the bits. So we need to return a chunk type. Okay, with bytes value. Oh, and this needs to be wrapped inside an OK. All right, this looks good. All right. Oh, I forgot. We should also derive. Should be, I think, EQ and partial EQ was mentioned in the exercise. All right, from string. I think here we're defining the error type, the associated error type, as the error that's defined here in main. Let me go back. Okay, so we're getting a string, and we need to create the chunk type. Let me go back to the documentation. I mean the specifications. In here, so we can't have any numeric values. All right. I think I'm just going to remain here. Let me go back to the IDE. So in case we have numeric values, we should return an error. So we have the string. Let's just do chars on it. Let's start the condition. So let's use the any adapter. So if any of the chars are numeric, I think we need to pass in a closure. Let's just say value dot, we have a method value dot is numeric. In this case, we should return an error variant. Can I just do, I think we can just create the error from the string. Let's see, error from, can I just give it a message? Numeric values not allowed. Okay, I think this is just complaining. Oh yeah, because I'm not giving the OK return type. Let's handle that. Otherwise, we need to create the chunk type. This should have the bytes field, width. With the byte values from the string, which should be, let's just try as bytes. Try into. Okay. I think we're getting two results. Oh, that's good. It was only wrapped in one result. Okay, this is looking fine. And I'm just gonna leave the unwrap here for now. And here, let's use the write macro. I'm gonna give it the formatter. And this should be self. Let's just try. So string from UTF-8 self dot bytes. Okay, I think this can fail. Okay, this is a vec. Again. I think we're just not closing this. Okay. So this is the error chaining for the try into, and this is the error chaining from the from UTF-8. I'm curious. Let's see cargo test. Okay. I think in the test it tries to format it with debug. Let's also derive debug. Let's try again. Huh. Okay. So we're not able to format the errors as we wish. I think this is a bit complicated. Let's close this for now. So the problem would be, for display, we have to return this type of error in standard format, and we're returning standard error. I think I can just change these to unwraps. It's not so important now. I think this should be good. Okay, so it compiled now. But we have some failing tests. The good news is that 8 of them passed already. So we just need to handle these, and I think we just need to handle the leftover methods. It's good. All right, let's close this for now. And let's see. Bytes, this should just return the bytes, not this hard-coded thing. This just be self.bytes. That's good. Is valid. We're going to need to check the documentation for this. Let's see. Here we have the description of the property bits. Let's check. Huh. Oh yes, I remember. This is a bit more complex. So let's just handle each byte on its own first, because valid will have to involve all of these. Okay. Save to copy. Let's go back to the IDE. First we have is critical. And I think... Okay. This is critical. Okay, and it's critical if it's 0, uppercase, or lowercase means it's not critical. Okay. So that would be self.data. Let's get the first bit from this section. I think I can just... Oh, it's called bytes. The first element is ASCII uppercase. Let's check. Does this fix more tests? Okay, 2 more tests passed. Public, I think they're in order. Public is the second one. Okay, private bit. So it's public, it's if uppercase. Okay. Let's see. The same. Okay. Is the next one the reserved? So this one must be uppercase. Oh. So it should be about the same thing. And save the copy. Let's see. Oh, this one is the reverse. It has to be lowercase to be safe to copy. All right. Is ASCII lowercase? Let's test again. Okay, only one test failing. That should be the is valid one. All right, let's see. Let's go back to the docs. So if I remember correctly, this has to be uppercase. Okay. Yes. Otherwise, it's invalid. And I think other than that, all we need is just for it to be ASCII letters. So yeah, from A to Z uppercase and A to Z lowercase. No numeric or no other symbols. Okay, let's go back to the IDE and handle that. So can call self.is reserve bit valid, and we also need to check if all the bits are ASCII characters. So let's say self. I think we can iterate. Oh no, self.bytes. Let's turn this into an iterator. Or can I just do? Oh no, it doesn't have chars. I'll just keep this into iterator, and we can use the all adapter, which will check every value in the collection against the condition. And let's give it the closure for each character. Bytes, because it's not a char, it's a U8 that represents a character. This is ASCII, and this should be enough, I think. Let's test again. Great. So all the tests are passing. And this kind of finishes the section we were on. So in case the last part was confusing, the chunk type is made of 4 bytes. Each byte can represent an ASCII letter, and each one can be verified for these properties. And this talks about bit 5, but essentially you can just kind of shortcut it by checking if the character representation of the byte value is uppercase or lowercase. And the case represents one of these properties, and we just check them to define those methods for the chunk type. Okay, we're going to wrap up the video here, and we're gonna cover the rest of the points in the assignment in upcoming videos. Let me know what you think of this format, if you like this kind of live coding video, or if you'd prefer presentation style videos as well. I would really appreciate your input. Thanks for watching, and take care.